Okay, in this review video, we're going to talk about different ways to represent division. So we're going to take a look at 2 2/3 divided by 3/4, but before we do, I'm going to take it back to a very basic first, second grade math when students were just learning their fact families. So a fact family is anytime you have three numbers that equal something. So I'm going to use 2, 5, and 10. You can take the numbers 2, 5, and 10, and we can do 2 times 5 equals 10. We can do 5 times 2 equals 10. Students know that the commutative property, you can reverse these. So we could do 2 groups of 5 and we can do 5 groups of 2. This goes way back to like third grade when students were just learning how to multiply. So we can just do like 2 groups of 5, which would look something like this, okay? So 2 groups of 5, or we could do 5 groups of 2, which would look something like this. 2, 3, 4, 5. Oh, that's 2 groups of 5. Sorry, I could do, let me do it the other way around, this way. 2 groups of 5. 1, 2, 3, 4, 5, 6. Because this goes back to like third grade, guys. So again, I haven't done area models in a long time, but students do have this foundational skill. So you can see how I can kind of divide it up and see how we have 2 groups. Sorry, like that. And then we could just go straight down. Okay, so multiplying, we could look at it 2 different ways. And the students used to know like horizontal and vertical. Now, when they started to learn to divide, we helped them understand that multiplying is just, division is just multiplying in reverse. So if we know 10 and we need to divide it by 2, then we know the answer is 5. And if we know 10 divided by 5, then we know the answer is 2. This is the foundations for algebra because when the students start to work with numbers and they're missing, for example, 5 times what equals 10, then students pull from their knowledge of fact families to say, oh, well, if 5 times blank equals 10, then 10 divided by 5 will give me that blank, okay? So again, this is something that's very foundational, and students should understand that if they have a division problem and they're seeking the answer, another way to do this would be to reverse it and say what times 3/4 will give me 2 2/3. Okay? All right, so how can we represent a division problem? So again, I just did 10 divided by 2 equals 5. Well, what if we didn't know what that answer is? So we would say, okay, if I want to figure this out and I want to maybe illustrate it or draw a picture, I can use multiplication. I can count up. Count up is just multiplication if I don't want to divide. So I can say to myself, how many 2/3 or 3/4 can I make with 2 2/3? Now, this would be like if I had a rope, right? If I had a rope that was 2 2/3 and I needed to break it down into 3/4, right? So if I had this number line all the way out here and I had to group it into 3/4, so that would be 3/4, 3/4, 3/4, and I'm just showing you how many of these 3/4 can I make with that space. So what we're doing there is a multiplication problem. So we're saying 3/4 times what number equals 2 2/3. This would be another way we could represent it. The question mark is still there. We're still figuring out the answer. 2 2/3 divided by 3/4 is the same exact thing as 3/4 times something, which will equal 2 2/3, just like this over here, just like our fact families. Now, in 6th grade, and 5th and 6th grade, they learned that keep, change, flip strategy. Keep, change, flip is just another way that we can represent a division problem. So we could do 2 2/3 divided by 3/4. We can do 3/4 times blank equals 2 2/3, which is just counting up. Or we can use the algorithm, keep, change, flip. So we could say 2 2/3 times, not question mark, we're actually going to use the 3/4, but we're going to use 4/3. And that will also give us the missing number. So we can use division. Okay, we can just divide. We can use multiplication, which is just the division problem in reverse, or we can use the algorithm for division, which is the keep, change, flip. Okay, so all three of these will get us that answer. Now, what does it look like? What does it look like in math? Okay, so 2 2/3 divided by 3/4. Now, we could use a calculator for this. Our brains have a hard time dividing. That's why we learned the algorithm. So, in order to do that, though, we need that to be an improper fraction, right? So that would be 2/3, which is 6 plus 2 is 8. So this would be 8/3. So we could do 8/3 divided by 3/4. And we could just use a calculator, right? I mean, if we're at the point where we just need a little extra support, we could just put 8/3 divided by 3/4 into the calculator. So I'm going to do that. Okay, 8/3 divided by 3/4. I'm keeping it exactly the same. Now look, I get this weird 3.555555555. It might be best to keep it as an improper fraction, 32/9. 32/9, okay? And for those students that are in the room who know what this repeating decimal is, and if you're not sure what it is, we can actually just copy and paste and put this in the calculator, and just it'll help us with what this is. The only problem is we might have to just keep going with the 5s because it's one of those run-on fractions. See how I put all the 5s in here, and you see this little fraction? Oh, this is 5/9. Okay, so this would be 3 5/9. And I would even encourage the students not to use the decimal, either use 3 5/9 or just keep it as 32/9. Okay, now let's use the next strategy, the number line. Okay, so now this is just use a calculator, right? If we're using a calculator, okay, if you're using a calculator, this would be fine. But notice that the answer that we got was a run-on decimal. So we might need to use that conversion. Okay, 3.555555555, and that would look like this: 3.5555555, or we could say 3 5/9. Or we can leave it as that improper fraction, which was 32/9. Okay, now let's use the number line. I kind of like this one better for this particular question. I just find sometimes the number line is just a little bit easier. How many 3/4 can I make with 2 2/3? Now remember, to use the number line, we have to have the denominators the same. So what can I count by? 3 and 4 and land on that same number. So 3, 6, 9, 12, 4, 8, 12. So I know I'm going to put my number line as 12ths. Okay, 12ths. So 2 2/3 is the same thing as 2 and what 12ths? Well, 3 times 4 is 12. 2 times 4 is 8. And then I'm going to divide that by 3/4, and 3/4 out of 12 is equal to 9/12. Okay? All right, so let's see what it looks like on the number line. 2 8/12 divided by 9/12. All right, so I'm going to come down here. I'm going to change my fraction to 12ths, and I'm going to find 2 and 9 8/12. I got to scroll over a little bit. It's a lot. We're going to count by a lot here. 2 and 8/12. That's where I've got to get to. Remember, 2 and 8/12 is the exact same thing as 2 2/3. Okay? It's the same thing. 2 2/3. Same thing. All right, and I'm going to divide by 9/12. Okay? And 9/12 is the exact same thing as 3/4. The only thing I'm doing is making my denominators the same so I can use the number line. All right, here we go. Let's find 9/12. Go back to the beginning, use a number hopper, turn it on, slide it over, 9/12. Bam. Now watch. Click on it and just hit plus. Plus, plus, plus. Okay, so now I went past. That's okay. We went past. Let's see how many holes we have. We've got 1, 2, 3, but I can't say 4. Okay, so I know the answer is going to be 3. 3 and something, some leftovers. Now we already know the answer. We already know the answer is 5/9. So let's see how we could do it with the number line. All right, divide the last bar into the sections. Like, see how the number line. Now all I'm doing is just cutting it. I'm just seeing how much of this I'm using. And I need to stop right here. See that? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm using 5 out of 9. That's what I'm using. 5/9. And that's my answer. This is probably a little bit easier than using the standard algorithm. Okay? All right, now keep, change, flip. Down here, keep, change, flip. If I want to use this strategy, I do need to make my mixed number an improper fraction. So we're still going to have to do that. 2 times 3 is 6, 7, 8. So this is 8/3 times 4/3. And that is going to give me 32/9, which is exactly what we had in the calculator. 32/9. Okay, so let's go ahead and pull it out in the calculator. 8/3 times 4/3. 8/3 times the reciprocal, 4/3. Okay, look, 3.55555555, 32/9. Okay, or we could make it a mixed number and say that it is equal to 3 5/9. All right, so again, students we've been really practicing with this, so this should not be new to them. We've really been working on this. They should be able to recognize that a division problem can be written as a multiplication problem with a missing number, or it can be written as a multiplication problem using the keep, change, flip. But it's so important that they flip that second fraction.